Hey guys, how are you doing? I'm so sorry this is late. I am not having my video on because looking like a crazy lady. I went to the gym. So I totally incredibly apologize for this tardiness. So the only thing I need for you guys to do tonight is just to take a look and write down the notes and then just upload them. I don't have any problems on here for you to try. So, or maybe I do. We'll see. All right. So again, we're still with section 4.1. Oh my heavens, but this is the last piece of it. We're going to talk about linear and angular speed. Okay. We'll start with angular speed. It's a little strange, but given an object with a fixed speed that is moving in a circle that has a fixed radius, you can define the angular velocity. Speed is velocity of the object. That is, we can determine how fast the radian measure of the angle is changing as the object moves on its circular path. So the important piece here is the radian measure. Okay, so again, remember how we were talking about arc length and area of a sector, that it was in radians? This thing is still holding true. All right, oops, so let's take us down here. Linear speed measures how fast the particle moves, while the angular speed measures how fast the angle changes. All right. You guys are very familiar with linear speed. When you go on the highway or you go on Riverland Street, you have 30 miles per hour. That is your linear speed. Angular speed, all right, does not incorporate the radius. Okay. So we take a look. Here is our angular speed. This is called a, let me get this going, an omega. All right. So theta, which is your angle, divided by time. And again, theta has to be in radians. So this is radians over time. All right. That is your angular speed. Now we take a look at linear speed. Linear speed, the only thing that it takes into consideration is that arc length. Okay. And the arc length, if you think about, we have theta times r, right, is our arc length, r times theta. And we have to take into consideration our time. So we're dividing by time. Or in other words, all you have to do is take your angular speed here and multiply it by the radius. All right, miles per hour. You can write it these three different ways. Miles per hour with the word, this still says per, even though it has that line, or mph, that's miles per hour. Okay, that's the difference between linear and angular. And again, both must be in radians. Very, very important. All right. So we have a second hand of a clock, 8 centimeters long. Find the linear speed of the tip of this clock as it passes around the clock. All right. So a couple things we need to think about first of all. We have one revolution, right, which is your arc length. That's what we're doing. We're going around the clock space, right? So we have here one, I'm going to do it in a color that we can see, one revolution. Okay. I shouldn't, sorry, let me erase that. Backtrack, sorry. One revolution is equal to 2 pi radians. It's also equal to 360 degrees. All right. It's also equal to 1 rotation. Just so you know, all of those equal the same thing. So this is asking for the arc length traveled. All right. Arc length is, oops, sorry. We have 16 pi. All right. If you remember arc length, we have 2 times our 2 pi times 8, which is our 16 radians per centimeter. And this is it multiplied out. All right, so that is our arc length, but now we have to take the second hand, right? And we have to take into consideration the time. We're talking about seconds, right? So it took me 16 seconds to get around, 60 seconds to get around, right? So when we do this, we need to divide it by 60 seconds, okay? So doing that out, we have 16 pi divided by 60 seconds, and we come up with this centimeter per second. And the centimeter is coming from this piece up here, right? We had 16 pi centimeters, okay? So you want to multiply that out. So it takes 0.8378 centimeters per second for the second hand to go around when the radius is 8 centimeters. So if you guys remember the, I gotta think of the word, in chemistry class, I can't believe I can't think of it. I'll think of it as we go along. All right, so let's take a look. The circular blade on the saw rotates at 240, let's try it again, 2,400 revolutions for 1 minute. They want to find the angular speed in radians per second. All right, so we need to change the revolution to radians. So that means I'm going to take it by 2 pi radian, and that's the same as 1 revolution. I'm multiplying by 1, so I'm okay to do that. All right. So now that will get rid of the revolution, and I'm left with radians per minute, but I need radians per second. So therefore, I need seconds. Sorry. I need seconds on the denominator. So 1 minute is 60 seconds. That gets rid of my minute, that gets rid of my minute, and I'm left with radians per second. So just on your calculator, 2,400 times 2 times pi divided by 60, and it will give you an answer of, oh, sorry, my arm keeps hitting things, 251.33 radians per second. Okay. All right, now the blade has a radius of 4 inches. Ready? You guys are going to be laugh at me. Dimensional analysis. That's what this is all to the T. So the blade has a radius of 4 inches, and they want you to find the linear speed in inches per second, then feet per minute. Well, we already know it's 251.33 radians per second, right? But we have to multiply that times our inches, our 4 inches. And that's just over 1, because that's our radius. We take the angular speed and times it by the radius. This will get me inches per second, which is what I want. So just multiply those two numbers out. All right, and then they're asking for feet per minute. So I have to change. I have inches, right? And I want to change it to feet. So 1 foot is 12 inches. So my dimensional analysis cancels those out, right? So now I'm left with feet per second. I know the radian is still in there, but it's an assumed unit, so don't worry about it. Once we put the linear piece into it, it's just incorporated. So now we're left with feet per second, but we need minutes. We need 1 minute down here, and then 60 seconds. All right. And like I said, that fundimensional analysis, very simple. Take this, multiply it by this, multiply it by 60, divide it by 12. And you should get inches per second is 1,105 inches per second. And the other one, my radians, which I did up there. Did I get 80? Yes. So it works out. Okay. All right. So again, angular, no radius, linear, radius. All right. We're going to do lots of word problems tomorrow. That's not our homework for tonight. We're going to do lots of word problems tomorrow, and we'll see you then. Again, sorry for the lateness. Okay, bye.